And so we're on page 504, please. Looking at this set of data about football. There are 16 teams in the National Football Conference, and each one of these is the number of touchdowns they scored. The median looks like it's 37. The lower quartile is 31. And the upper quartile looks like it might be 45.5. Because remember, the lower quartile, the median, and the upper quartile. Quartile stands for what? What does quartile stand for? It's a quarter of the data, so it's breaking all of our data up into 4 equal chunks. A box and whisker plot, then, is a diagram that's constructed using those 3 points and the extreme values. So what happens is you plot the minimum, the lower quartile, the median, the upper quartile, and the upper extreme, or the maximum. There's a whisker, box, and a whisker. So it's called the box and whisker plot because there's a box with little whiskers on it. Okay? The median is a big line in the middle of the box. So you know, between here and here is 25% of the data. The whisker stands for 25. This box is 25, and this box is 25, and this whisker is 25. The whole box together then is how much information? 100%. No, how much is in the box if it's 2 of the quartiles? It's 2 of the quartiles. So it's 50% because there's a quartile here and a quartile here. Remember that interquartile range is how big it is between the upper and the lower quartile. The interquartile range is how big the box is. It's how wide the middle 50% of the data is. So we aren't using any new points. We're just making it easier to see. This helps us figure out how it's spread out. If we have a really long whisker, that means my data spread out really far. If I have a really short box, then that means my data is all scrunched together. So the reason we care that we couldn't see last week about those points is because it tells us how the data is distributed, how it's spread out. Remember, measures of variation are how the data is distributed, how it's spread out. This tells us way more than just one number. This tells us way more than the average. Each chunk is 25%. And so, if we had data, and we're not going to do this example, but if we had data, we would start it the exact same way. We would put it in order and find those 5 numbers, the minimum, the lower quartile, the median, the upper quartile, and the maximum, those 5 numbers we found last week. But now we're going to put it on a number line. This is just like if you graph something. Notice that everything is spread out evenly first. 7th graders do that wrong. I don't know why. It drives me crazy. You don't put the 5 numbers down here. You go, they're counting by 5s here. They're actually counting by 1s and labeling it every 5. Then you put the dots where those 5 numbers are. The lower, or the minimum, the lower quartile, the median, the upper quartile, the upper extreme. And then whisker, box, whisker. Okay? Huh?
No, but if you're going to buy it.
Oh, yeah, they're going to march. So we're going to do some of this together. And ultimately, we want to be able to compare. So this is why we care about making a box and whisker plot, because it makes it really easy to make some comparison statements. This is the part where you actually use data to make judgments. So, there's Superfit and the Athletic Club. Compare and contrast the range and the variance of the attendance. What do you notice about where the box is located? Which one has higher attendance? Superfit or the Athletic Club? Which one has more attendance? Take a look at the box. Which one has more attendance? What do you think, Morgan?
The Athletic Club.
Tell me why you think the Athletic Club.
Because it's 57 and 110, and the Superfit has 53 and 72.5.
Okay, so you said if I pick the minimum and the maximum, The minimum is bigger and the maximum is bigger. That's one good statement. Someone make another statement. That one I think is just okay. To be honest, I don't necessarily think that that's the best answer they could give. What do you think, Jaden? Oh, look at that. That's a great statement. I'm going to say that so it shows up. He's saying that the box goes from 65 to 80. So all of this box is higher. How much data is in the box, by the way? How much data is in the whole box? How much? 50%, because it's a quarter and a quarter. So 25 and 25 is 50. This middle box 50% is higher than this whole middle box 50%. Jaden, that is outstanding. He's saying the whole darn box. Look at that. Well, wait a minute. Can I build on that, Jaden? If I have those two and a whisker, now what percent is that? If I have two boxes and a whisker, what percent of the data? What percent is in each quartile? Okay, so I have three of them. So what percent? So 75% of the athletic club, these three quartiles, is higher than what percent of Superfit? Oh, wait, I've got a whisker in the box below that. What percent is below athletic club's lower quartile? I've got a whisker in two boxes. What percent? Lindsay? No, I got 25 here and 25 here and 25 here. How much total, Lindsay? So Jaden said, well, this 50% is bigger than this 50%, right? Well, couldn't I also say that that 75%, because there's three of them, is bigger than this 75%? Most of the athletic club data is bigger than most of that data. That's perhaps the most powerful statement you could make. 75% of the athletic club data is higher than 75%. Or, ooh, look here. You could say that what percentage? I've got two quartiles. What percent of athletic club stuff? If I've got two quartiles, what percent is that? So 50% of athletic club is bigger than how much of Superfit? How much is four quartiles? 100% says Nate. So I could say 50% of the athletic club is bigger than what percent of Superfit? No, it's 1, 2, 3, 4 quarters. 50% is bigger than how much of Superfits? Say it, someone just said it. All of it, 100% of it. Half of the athletic club attendance is higher than all of the Superfit attendance. I think I like that one even better. That's a really powerful statement. You're saying half of their attendance is better than all of their attendance. That's a really powerful statement. Now you're not just talking about straight numbers. So this one's just okay. But the reason I like Box and Whisker Plots is because you can talk about how 25% of the data is bigger than another chunk of the other data. Those are the comparison statements we're going to make. What questions do you have? Because some of you are just all staring at me because it's Monday. That's not good enough. Tell me what questions you have. It all makes perfect sense to you and you could make those statements? For real? Someone say, Mrs. Smith, what's the star about? What do you think the star is about? What's the star about if you had to guess? Why do you think there's a star on this one?
Special?
It is special. Why? Why is there a dot way over at 110? It's not even connected to these other things. Why? What do you think? What do you think, Draven? Ah, it is an outlier because it is so far away from this middle 50% that it gets a star instead. Otherwise, this whisker would be really long, right? It would make it seem like all of the data spread out when in fact it's just this one data point. What question?
So